As you may have already witnessed on your own, electronic components can be destroyed by excessive current. And since current flow generates heat, it can also be a fire hazard. To firmly grasp the concept of what voltage is, let's go to an analogy we're all familiar with, running water. The circuit is kind of like a water pump with a valve attached to it. With our water analogy, the pump produces the pressure we need to push the water through the pipe. We can think of this pump as a battery in our actual circuit, as they both produce a pressure. One's electrical pressure and the other's fluid pressure. Next, we see the valve. The valve is like a variable resistor. When it's almost all the way closed, very little water flows. When open all the way, maximum water will flow. So, the valve is analogous to the resistor in our circuit. Finally, we have the water itself. The water flowing through the pipe is like current flowing through the circuit. Just as the current in the electrical circuit does work by lighting the LED, the water can do work if, say, we set up a water wheel at the end of the faucet. In fact, utilities often use water in hydroelectric dams to generate electricity. Notice that like excessive current, excessive water pressure can be dangerous, and the more pressure the pump applies, the more water will flow. If we allow too much water to flow at once, the pipes may burst, or the excess pressure may damage the faucet. Similarly, excessive current can fry the LED and make the wires hot, therefore burning them up. A higher voltage causes this excessive current flow, just as higher pressure from the pump causes more water to flow. So now we know that voltage pushes current through a circuit to do useful work. The higher the voltage, the higher the pressure. This means that current and voltage are proportional. If we increase the pressure in the water example, say by getting a bigger pump, more water would be forced through the pipe. It would come out of the faucet at a higher speed and pressure. Ohm's law tells us this, but intuitively we know that applying a higher voltage to the circuit will make the LED shine brighter, assuming the resistor remains the same value. It's not the voltage that makes the LED brighter, it's the current. More voltage means more current flow. One more important point to note is that when we measure voltage, or someone says something like the voltage at point A is 5 volts, is that we are measuring voltage with respect to something. We hinted at this earlier, but here it is again. Only differences in potential energy are meaningful. For example, when measuring voltage across a resistor, we're just measuring the voltage from point A with respect to point B, or one end of the resistor with respect to the other end. The resistor causes a drop in the pressure or voltage. So, measuring voltage across a resistor is the same as measuring electric potential difference from point A to point B. Often, you'll measure voltage with respect to ground, which is the lowest voltage in a circuit, usually 0 volts. The meaning of ground itself is often confusing, so we'll probably do a lesson on that in the future. So, for example, if I wanted to measure the voltage at point A in this circuit, I put one of my meter probes at point A and the other at ground, since I'm measuring the voltage at A with respect to ground. Measuring voltage with respect to ground is the same as measuring the potential difference between ground and some other point in the circuit. Now that we know what volts are, at least from a bird's eye view, for those who just want to scratch the surface, the concept of voltage as electrical pressure fits the bill perfectly. On a low level, there's more to the story of voltage. This story involves electric fields and calculus, stuff that's beyond the scope of what most hobbyists need to know. Because of that, we'll leave the low-level scientific mathematical definition of voltage and electric potential to the universities and engineering textbooks, at least for now. But perhaps doing such a lesson in the future would give me a good excuse to blow the dust off my physics and electromagnetics textbooks. It would be an advanced one, no doubt, but it would be a good review for engineers, advanced techs, uber nerds, and even myself. Until next time, break out the Arduino and make something.